All right. Hello, everybody, and welcome to today's AMA on programmable cryptography. My name is Bastian. I lead the investments of the CV Labs Accelerator. And today I'm joined by Anthony, who's the head of strategy and marketing of Midnight. We've got Jason, the blockchain ecosystem lead of Zama, and we've got Marcus, founder of Ubitel and one of our portfolio companies of the most recent acceleration cohort. So to get it started and give you a bit of a background or what we're talking about today, I want to give you a quick, brief background on programmable cryptography. So cryptography is undergoing a generational transition from special purpose cryptography to programmable cryptography. So first to understand, okay, what is special purpose cryptography? So essentially, it's a protocol that allows us to perform a single operation with cryptographic guarantees. Think of public key encryption. And so over the past 50 years, special purpose cryptography has become an irreplaceable component in the global communication stack. For example, almost all data transmitted on the web today passes through cryptographic protocols of some form. Think of, for instance, HTTPS. If you log into LinkedIn, YouTube, you don't want to share your passwords. Now, if you go to programmable cryptography, we use the term to refer to a second generation of cryptographic primitives that are becoming practical today. And I guess the defining feature of those primitives is that they're far more flexible than first generation cryptography. And this allows us to perform general purpose computation. And so examples of those programmable cryptography techniques are first fully homomorphic encryption. So we're going to get into this later with Zama. And essentially, FEG allows me to compute an arbitrary program over someone else's private data without learning anything about the data or the output of the computation. So I can, for instance, send my private data, to some program. They run the program, they don't see the data, and also they won't see the output. Then there is multi-party computation, so MPC, which is sort of similar of what it tries to achieve. It allows me to compute arbitrary program over multiple people's private data. So essentially, you share the data with multiple parties, and they will not learn anything about data except for the output. So here you would know the output. And the third really big thing at the moment, especially in blockchain, is CK snarks. Which allow me to prove an arbitrary piece of code that was executed correctly on some secret that only I know. So essentially, we use it to compute off-chain and then take the proof on-chain. And then there is two more, a little bit less known, which is witness encryption, which allows me to encrypt a message to a program, and obfuscation, which allows me to encrypt essentially an entire program. And so those first instances of programmable cryptography have just started to become practical for developers in real-world use cases over the past 5 years or so. And in the coming decade, the performance, accessibility, and capabilities of programmable cryptography will increase dramatically. And so this obviously leaves us with the question, what might the transition from special purpose to programmable cryptography enable, and how will we get there? And this is exactly where I would like to introduce the panelists. So maybe we can start with Anthony. Please introduce yourself quickly and also the project you're working for, and obviously your touch points with programmable cryptography.
Brilliant. Thank you, Bastian. Excellent introduction. I'm very impressed that you managed to learn all of those and run that all off pat. Very impressive start, very nice, concise summary. To give you our side of the world, so my name is Anthony Day, I work for Midnight. Midnight is focused on using zero-knowledge technology, focused primarily on client-side proofing technology, which means that no data ever leaves your system, your device, your network, with that being the goal of, let's call it gold standard of data protection. So if the data doesn't move, if it remains within your control, it can't get more secure than that. And where we see that being important is pretty much anywhere where you see sensitive data transacting or being moved through a decentralized application today. We're risk accepting in most cases that we're using public blockchains, appending transactions, wallet details, albeit pseudonymous, on public blockchains. And unfortunately, we know that that's a barrier to the adoption or the moving on chain of $20 trillion of real world assets, or the use cases that we've seen and heard among enterprises, or just individual peer-to-peer activities, decentralized social, decentralized physical infrastructure networks. In all of these cases, there's a requirement to keep a secret. And so our focus is on enabling that to happen across as many chains as we can work with. So our basic architecture, the blockchain is built on Substrate, the proving system is based on Halo 2, and we'll get into more details as we go through, but hopefully that's a helpful start.
Absolutely perfect. Thank you so much, Anthony. Yeah, privacy is key for a lot of applications. And now I would like to go over to Jason from Zama, and please tell us a little bit more on what you're building, and also maybe what FHE is in more detail, and how people actually apply FHE today.
Thank you for having me. So I'm working for Zama. Zama is a cryptography company working specially on FHE. FHE is fully homomorphic encryption. So as you described perfectly, FHE is the ability to do computation over encrypted data, which means in the context of blockchain. So we have two areas. We're working on blockchain and on machine learning AI. So I'm more focused on the blockchain part. And what we have is a product called an FHE VM coprocessor. Long words, but it means that we enable the smart contract developer on Ethereum to manipulate private states, encrypted states, and all the computation is done off-chain on our coprocessor. And so the basic example of this is you can have a private ERC20, private in the sense that the data itself, the balances of a stable coin or an asset is encrypted. So if I send you 10 tokens, only me and you can decrypt the 10 amounts, but anybody else will see on a blockchain explorer a bunch of ciphertext that they cannot describe. And more generally, we are asked a lot what's the difference between FHE and ZK. And so ZK can be used for privacy. It's mostly used today for scaling the blockchain, for the succinctness of the proof, not for the zero knowledge part, mostly, I would say. And the main difference is with FHE, you have all the encrypted data, the sensitive data on-chain and encrypted, and you can still have the composability of the blockchain, which is an amazing feature. And you don't need a specific language. You can use Solidity with new data types as a developer. So you have uint addresses, Boolean normally, but with FHE, you can have E addresses, encrypted addresses, and encrypted unsigned integer, encrypted Booleans, and so on. So you just have a new simple toy to add a confidentiality and privacy to your blockchain.
Awesome. Fantastic. Thank you. And now over to Marcus from Ubitel. So you worked, or you led a team at the Ethereum Foundation PSE, now building your own DP network. So in terms of more the application side, how are you applying ZK and what are you doing? And you're also building your own TEs, right? So please tell us a little bit more about it.
Yeah. So there's a bit of synergy there. Yeah, my name is Marcus. We're building Ubitel. We are decentralizing layer 0 with the DISP, like a DeepIn ISP network. Yeah, and so there's lots of really cool ways that we're applying all this new programmable cryptographic technology. The first, probably the most interesting thing is we're decentralizing the root of trust that exists in ISPs. Every ISP is actually really, really bad about this, and this is how you get SIM swapped, how a lot of your data gets stolen, unencrypted, stuff like this. Yeah. So one of the really cool things that we're doing first off is leveraging ZK for identity, right? So semaphore type proofs for identity on the network, and then we're also upgrading basically how cellular networks work with actual ECC cryptography instead of pre-shared AES keys. And so we have lots of plans kind of going forward, but yeah, the way that we're really kind of getting the heart of the centralization here is we're actually building a secure compute network of TEEs that are based on SIM cards. So basically everyone with a SIM card, eSIM, etc., kind of contributes to this TEE network, and then we're able to do some really cool DKG frost type stuff to actually not trust in the network. So that way, a DAO can own this. So yeah, super bullish, ZK hardware. co-processors, things like this. Yeah, I've been in the space for a little bit, and one of the things that excites me is like the tooling is just getting phenomenal now. I remember some of the first ZK stuff like Socrates, and it's like, what the hell do you do with this? But it feels like we're almost like one ZK.fun away from like just a barrage of applications. So that's,
I mean, that's actually good. That's actually a good point that I wanted to discuss later on. But you can also take this point now. I mean, if I wanted to get started in, I don't know, FHE, CK, whatever, I'm quite familiar with different tools and for instance, or I just graduated from computer science school. I want to build something cool with CK or FHE, and obviously most of the professors probably wouldn't know themselves, so I got to teach it myself. Where do I learn those things? I wanted to build it with Zama on FHE or use some CK stuff. How do I get started? What are the tools?
I'll take that one to start with, because I think I've definitely echo what Marcus said, is that the tooling is getting easier now, that as far as possible, the ZK parts, with the exception of maybe architecting your applications around the concept of circuits, is becoming much less important for you to know inherently. Right? The goal here is that you're just able to program a regular smart contract that makes use of the services, whether it be FHE, MPC, ZK, whatever it is, so that you're just programming. The infrastructure does the rest, and the data protection, the privacy, the selective disclosure, whatever it is that you want, are the modules or the features that you get to plug into your app. That's the goal, and we're not far away. I could talk to the Midnight side, which is smart contracts on Midnight can be programmed in TypeScript. So you're using relatively familiar language. You're programming smart contracts in the way that smart contracts typically operate, albeit you have to learn a little bit about circuits. The other feature is selective disclosure and how you program selective disclosure at an application level. Right now would be manual. 6 months down the line, there'll be plugins, there'll be Open Zeppelin examples, there'll be open source examples on Midnight and on every other project where people can just take those well-established, well-tested, peer-reviewed modules and use them again. We've got there in Ethereum. As I said, I think we're about 6 months away, or maybe even less, from having that in these sorts of ecosystems, which I think is super powerful.
Yeah, that sounds awesome. How about using Zama? What's the easiest way to get started?
So the good news is we just shipped the product on Ethereum Sepolia 3 days ago. So it's live in the sense of a test net. It's been lots of work because the FHE part is actually the simple part. Actually, our product, to make it work, you have to prove some stuff in ZK. You prove that you know the plain text of your ciphertext. There is a decryption key which is split in an MPC threshold decryption network. Each nodes are running a TE. So we are just a single privacy enhancing technology cannot work alone. It always works with all of the rest of the stack, but I'm not answering the question. So how to get started is quite easy. We have an amazing documentation, and as I said before, our product for developers is entirely based on Solidity. So you don't need to learn a new language. You don't need to learn weird FHE circuits or stuff like this. So this is we believe a good simple developer experience, and you just need to learn to manipulate decryption, which is something quite new for smart contract developer concept, but we have great examples. So I would recommend to start just to build a private ERC20 contract, very simple, balances, transfer, adding and subtracting in FHE. That's very simple, and then from here. You could build something like an identity smart contract with claims, because also in FHE you can put your identity on chain because nobody can decrypt it, and then make the two smart contracts work together. We have lots of example of these specific example on our documentation, and if you have any problem, we have a full dedicated team on our Discord with Solidity experts in our library to help you get started.
Very cool, exciting. And so nice. You're currently in Argentina, right? Hosting a hackathon with Zama.
Yeah. So I'm personally flying tomorrow, but okay. We are progressively moving there with the team. We are organizing a hackathon there. around the concept of governance applications. And more specifically, we call it like state OS, because we believe that for the first time, you can build a real state IT infrastructure on chain, because most of the government use cases require confidentiality. So you cannot have an identity system without confidentiality. You cannot pay your taxes. You cannot have a land registry on chain. You cannot have any of these without confidentiality. And so, as we just shipped the coprocessor on Sepolia, we are expecting developer to build amazing use case. So we are targeting on the short term. I don't know if you heard of them, but network states, which are more like startup-like countries. We believe they will get started easier. But then, of course, our goal is to have this technology for like normal states.
Right, got it. And if you look closer to Midnight, Anthony, what do you expect to be like the first applications of Midnight? I mean, I think you went live for a testnet in October, right?
Yeah, that's right. I think this is, we see Midnight as a data protection and compliance technology for all dApps. And so where we're looking, or the dApps that we're seeing built on testnet, mirror quite clearly what is some of the earlier use cases for Web3, which is typically going to be in and around digital assets, identity management, gaming, for example. And then you're looking at where you'll typically find regulated industries. So clearly finance is a start. You might also see some enterprise use cases that we're exploring at the moment. Nothing we can share publicly, but again, where you see sensitive data or where there is data compliance required in certain use cases. So if you're going to compute on sensitive, let's call it identity data or healthcare data, or even finance data, in those particular instances, you may be required, or you may open up the opportunity to do private computation. But in future, you may then be required to selectively disclose certain information, maybe with your auditor, or if you're again, just through a compliance audit or process audit. You don't want to trust everything to the black box. And I think it's particularly important as we build familiarity with, as Jason said, governments and states or municipalities around the use of this technology. It's important for us to be able to show them the functionality of selective disclosure, because otherwise they have to trust the black box, or the governments have to audit the black box or the code of the black box. And the level of, if you go back to Malta, who were one of the first countries to do government smart contract auditing services, the challenges they had back 5 years ago now is getting enough talent to do government jobs to audit the smart contracts. It was a brilliant idea. It brought a lot of business to Malta, but the challenge is all the people who they wanted to do the auditing were off doing actual work in Web3 and didn't want to have a government job. And so anywhere where we're expecting this technology to be used in the real world, we've got to have some capability to demonstrate to them that here's how the technology works, or that we can build comfort for you in that particular code base. So as I said, anywhere where you see digital assets, digital identity, existing Web3 use cases with sensitive data is what we're seeing early. And then I think the fast follower for those will be decentralized physical infrastructure networks, data monetization, and dare I say it, AI. Are we allowed to talk about AI? Are we still talking? It's still 2024, right? We can still talk about AI.
We can.
Definitely private LLMs or LLMs that are trained on highly sensitive data models quickly. That's going to be super important.
Yeah, I mean, look, speaking of deep in networks, I mean, obviously Marcus is applying some of the techniques. Now, you're also like, as I said, like CKATs, or even like potentially FHE. And so the question is like, does it make sense to mix the different programmable cryptography techniques, or would you only stick with CK or the other? Like, does it get too complicated? What are the upsides of actually mixing them? So maybe this one is for you, Marcus, since you're the one applying those technologies.
Yeah. I mean, like, I think also like Jason from Zama like mentioned, it's like, there are definitely parts, if we want to create like this dope cyberpunk network state infrastructure layer, right? There's a couple things we need to do. Like, one of the first things is like, we have to sort of change a lot of the way the protocols work, but we also have to make sure that things are decentralized. So from my point of view, like, we use TE SIM cards to basically do this distributed frost threshold world thing that ends up deciding who's let on. Basically decentralizes all the control from me, or like what would normally be a centralized party, and like kind of gives that power back to the people. But then on top of that, you know, you kind of have to build in these sort of, in the way that we're doing it at Ubitel is we're trying to be like, oh, like just build this into the root layers so that it's not super noticeable to the end user, but it's like, you know, we want to make sure that everything is end-to-end encrypted by default. You know what I mean? We want to make sure that like we have all these bespoke tools that are in our toolbox of like programmable cryptography and, you know, decentralization. We want to kind of leverage them as much as possible. So 100%, I think it makes sense. And you even see like really, really cool teams like Cursive out of PSE who, you know, initially like we ported Baby Jub Jub over to smart cards for one of their initial iterations, but like, you know, they're doing MPC, FHE on sort of like their own, like it's not a roll up chain through as a TIMO or whatever. And like, that is a great example. Digital pheromones thing is like a great example of like cool things you can build when you mix those things together. So yeah, I don't think that any one particular lane in programmable cryptography is going to be the best. I think there's a lot of synergies to putting them together, you know?
It's a spectrum, right? And
Yeah,
as with all things, you're going to see certain use cases or certain industries that will require particular performance characteristics, whether that's speed, throughput. Verification time, I think, is universally quite quick most of the time. So it's the verification's less of the challenge, but certainly improving proof generation, that's part of it. The number of parties and the complexity of the computations, I think, and you end up in different places. And so from our perspective, we want to be at one end of the spectrum, but over the course of time, we want to see a midnight flavor with MPC embedded, a midnight flavor with TEE embedded, a midnight. So you have this kind of overarching house of privacy type of concept where the users want to work to their non-functional requirements. They don't want to be locked into whichever particular flavor you've designed. And we've got to try and find the aggregation at an architecture level to make that easy, consumable, and then you choose which project do you want to plug in. And you know, from my perspective, we're already having a number of really exciting conversations with MPC, TE providers. Like anybody who's out there, come get us. We're excited. I don't think like I don't want to see any chain maximalism. I don't want to see programmable cryptography maximalism either.
Sure. Yeah.
Absolutely. Perfect. I think we also have a couple of startup founders in the call. And so if you guys have any questions, like feel free to use the chat to ask the question in there. And then we're going to get back to the chat function later on. But meanwhile, for people in the call, so opportunities for startups. So what makes this field exciting for entrepreneurs? I mean, so for instance, if you hear the voice of Peter Thiel, he's always saying, yeah, you got to find the next big secret that nobody else knows. And I feel like every time we have a new field, there is automatically a lot of new secrets, so to speak, to solve for. But is it just a lot of buzz, or can we find new secrets and unlock new opportunities and possibilities with it? And if so, what are the secrets? What do you see?
This entire sector is about secrets, right? Or at least about keeping secrets.
Right.
This observation one is that this entire domain is about keeping secrets. I'll probably pass it quickly because I've been talking too much. But my observation here is that if you are an app developer or if you are working in Web3 infrastructure, your opportunity now is to take the tool sets that you see from all the different flavors of ZK or data protection and plug those into either SaaS infrastructure as a service to help others build apps with data protection, so that all of the existing DApp all the existing dApps you can build today are able to be built with privacy or data protection or compliance or selective disclosure. Anybody who can then level up on what exists today, right? Moving from VHS to minidisc or minidisc to MP3, the apps are probably the same. DeFi will still exist, right? It's just do them in a way that we can get more people onboarded, because you don't have the barrier of too much transparency.
Right. I mean, that makes a lot of sense. And the question is also like, what applications are, for instance, maybe not possible as of today, right? I mean, I think a big misunderstanding of blockchains is that, a lot of people say, it's just to hide currencies, hide money, et cetera, but like it's the most transparent way to actually send money, and indeed that is a problem, because it's difficult to create some payment gateways on the blockchain, because some people want to have privacy, right? You want to have privacy when it comes to your payments for your salary, and maybe government agencies also want to see some privacy. And I think this is also, where FHE, for instance, comes into play. Especially you want to have the government agencies to also then look at certain transactions if they have to.
Yeah, absolutely.
And so I think this is the exciting part about, programmable cryptography, where you can actually create new applications that just weren't possible before, not just to have a bit more privacy or so.
I guess it's the same for ZK, but with FHE, you have the possibility to have your access control logic in your smart contract written directly in Solidity, and so your backdoor, if you need to create one, even though it's not your compliance door.
Please don't call it a backdoor.
Yeah, no, the front door. Sorry. Yeah, so your front door, you can write it directly in access control logic Solidity codes on our FHE coprocessor, so that anybody can see that only you can decrypt your amounts, plus this regulator, under the condition that this law court give access to the regulator to the decryption. So all of this can be completely programmable, and yeah, if we zoom out, a little bit on chain finance or real world assets, chain links always share this diagram with the size of the trillions of assets in the real world. That's amazingly huge. Bitcoin is just 2 trillion. The debt market is like 300 trillion. Like we are nothing yet, and nothing will happen on chain. We won't move on chain unless we have confidentiality. That's not just gonna happen, and it's not because people need privacy. It's because like most business use case require privacy. If we want massive use of stable coins, no big company will pay its supplier using stablecoin if the amount at least is not encrypted. And so we believe that as you introduced it, Bastian, confidentiality will have the same effect on blockchain as SSL did on HTTP. An example I'd like to share is you couldn't really have credit card information on the internet before SSL. It was too risky. And then it unlocked all the e-commerce, all the marketplaces, etc. And we believe that the same will happen with on-chain finance. Once you have strong confidentiality, there will be massive flow of capital, and we are talking trillions.
Right.
Completely agree. Well, we did have credit cards before SSL. It's just we were risk accepting, and then we figured out it was bad, and then we fixed it, right? And it's exactly the same with Web3, right?
Yeah,
Everybody
that's the same.
There
are transactions.
Yep.
People are transferring billions on stable coins, but at some point the algorithm and the people auditing the blockchain will be too powerful. It will be too transparent. We are just a niche right now, but once it becomes critical for business, encryption will be needed.
Let's be clear. Also, metadata is a challenge too, right? So some of the projects that we've worked with in the past have the sort of the belief that it's enough to obfuscate the balance or the amount. But if you're looking at it may fall into DeFi, it may fall into anti-doxing technology, etc. Metadata, being able to track, even if the transaction, the details or the value is obfuscated, that transaction happened between multiple parties. Being visible on chain is also a challenge for a bunch of people, particularly CISOs who get very protective about those sorts of things. So being able to shield the metadata and not just the transaction data is something to keep in the consideration set.
Right, definitely a big topic. And I mean, data as an asset, obviously also a big topic. I mean, if you want to, for instance, set up a new trading account before using Binance, I want to set up Kraken, you got to go through the entire KYC process once again, because you can't really share the data. And I think this is also becoming more and more a thing, even outside of Web3, just to share the data from one platform to another with a cryptographic proof and without revealing it to outsiders. And so, yeah, if you had all the means to build your own startup, speaking of like you had the financial means, you had the best talent, but also cryptography is at the point where it's scalable enough, it's fast enough, it's cheap enough. What was the number one application you would build now, or what would you even like, Marcus? What would you implement into Ubitel at the moment? You had all the means.
Oh, what would I implement at the moment? Yeah, great question. Right, I would do. I mean, one of the things that we're building, I guess I should say, that we want to be implementing is like a zero knowledge proof of bandwidth system, right? And like that's super powerful. I would say honestly, like real value that lies in a lot of this programmable cryptography stuff is the fact that it can exist on a gradient of like, you know, of like a, you know, sort of like the opacity slider on like your Photoshop, right? And so I think this to me seemed like, you know, big businesses will adopt it fast, right? Because they can obviously choose here, you know, it's not like completely like Monero or something where everything's got to be complete, like very, very light. That's like obviously like extremely opaque versus like, you know, businesses, you know, of course, just want to see like, hey, like, did you maybe reveal your location to us, or, you know, something like involving the user. And this slider is super game changing, I think, right? So you can selectively disclose pieces of this around. So I think for Ubitel, one of the cool things that unlocks for us, right? Like we have all of this information about, or we could have all this information about which nodes you're connected to. You have to selectively disclose where you're at, right? But that can bring in powerful primitives like, you know.
Yeah.
Did we lose Marcus? I might build on the example that he took there, because there's an enterprise use case that I think is super powerful around, let's call it private commerce or private e-commerce or something like that. Have we got you back, Marcus?
Sorry about that. I was just lost connection there.
Talking about powerful cryptography, not powerful internet, but here we're back again.
Yeah. I mean, I think there's lots of cool use cases to like talking about. It's a pretty cool unlock. Where only if you can selectively disclose your location to people that can prove that, then you can sign the multi-sig, right? Let's make sure your CEO isn't being something,
or in a jurisdiction which isn't
like a privacy
allowed to make a transaction, or isn't allowed to be active in this particular airdrop transaction, whatever you care to call it, right? There's a lot of signing that goes on around aircraft leasing where you're required to be outside of country, so they do the signing while the aircraft is in the air, right? There's a deep end use case for that. Also.
Yeah, in international waters kind of thing. Yeah.
Otherwise, you have a taxable event, which is massive.
Sure.
So these things matter. There was another use case that I came across back in my Deloitte days. This was as I was just getting interested in ZK about 2017, 2018. There was a constant challenge where you've got data providers, specifically satellite data providers, who provide real-time surveillance of certain locations. And obviously, government entities are interested in that particular data for a bunch of reasons. And the challenge at the moment is that the government parties obviously have to KYC on the platform. And so you know that it's Mr. Smith from the CIA who's looking at your particular, or at least you go through the procurement, they are buying up your data. Now, if you are the CIA, or if you are any entity that requires information on a particular piece of land, you may not want others to know that you're surveilling that one particular location. And so what you want as a platform is the ability for people to pay for your services, but you may not want the ability for them to dox who they are and also what they're buying, right? So you've actually got a double blind purchasing system or double blind procurement system where the person is KYC'd, they buy what they want. The other side is comfortable that they're transacting with a party that's legitimate, but you have no idea what you sold them, which I think is just a super, super powerful use case. Like, it shouldn't always be about surveillance and dodgy shit, but that's one of those ones where there's plenty of other analogies around that.
Right.
Certainly.
So taking a question from the chat, when is Midnight going open source?
2025. We're working on it right now. I know there's been plenty of comments in our Discord in the community around that. We're going through a bunch of it. So obviously we're using a bunch of different components. We're using Substrate and we're contributing back to the Substrate libraries as well. So we don't want it just to be a one-way street. So we're looking at our contributions outwards, but also on the path to mainnet. Open source is definitely going to be part of the story. So 2025 for that.
Awesome. Perfect. And so speaking of roadmap, what is in the roadmap for Zama, Midnight, and Ubitel?
Jason, you go next.
Yeah, I can start. So we've just launched the coprocessor on Ethereum Sepolia. Next step for us is to gather maximum of feedbacks from everybody and to launch a real version on Ethereum mainnet. And once this step is a success, we will then deploy the coprocessor on all the main network where the liquidity is and where the use case are, where confidentiality is mostly needed. So it will be probably Arbitrum based, all the usual suspects, at some point Solana, obviously. But the hard part is to deploy this first version. So we'll expand to all the networks. We want to have an FHE coprocessor on all blockchains. And so this is on the FHE part. But as I said earlier, there is also a whole part of the infrastructure, which is the key management system using threshold decryption and MPC. And the first version of the key management system will be some kind of centralized. And in 2025, we want to decentralize it as much as possible because the KMS is itself a blockchain. It's a blockchain. And so we want to decentralize it as much as possible to create real trust on the decryption key. And this is the only way to attract lots of liquidity in our private ERC20 and in all the real world asset tokenized under our coprocessor.
Got it. What about Midnight's roadmap?
So we're in testnet now. So testnet launched 1st of October, and we're part to mainnet middle of next year. So in between that, there will be a token generating event. There will be an incentivized testnet, and there will be papers out covering both of those. Probably not before the end of December, but certainly the beginning of next year. So we're moving quickly. There's a lot going on. Please bear with us. We're trying to move quickly and pragmatically. We are also in the era of MiCA. So obviously we've got all of the exciting new compliance activity. We asked for regulation. We asked for these sorts of details, and we've got them. And so we're going through a whole bunch of that at the moment. We're trying to give the community as much of an opportunity to get their hands on their technology as we can right now, while knowing there's pieces of the roadmap we're still building. Midnight will launch as a partner chain of Cardano. So the Cardano community will probably get the first run at hybrid applications using Midnight. But the intent is, as we go through the token generating event and following on from that, we want to build bridges into the largest ecosystems with the largest number of dApps where data protection, compliance, selective disclosure will help onboard more users to more of the existing dApps that we have today. That's the goal. And so more details on the roadmap. You can go to midnight.network/white paper. That's in the chat as well. So if anybody wants to find out more, that's a good place to go. Also midnight.network, and you can get links to the Discord. Go talk to the developer relations guys. They're always happy to have new questions, new use cases. I saw a couple of questions. I think I saw John in the chat as well talking about colored coins or specific tokens on Midnight. Yes, that will be a possibility. So for all your Midnight desires, go jump in the Discord and ask the guys as much as you can. They're definitely not busy. They are busy. They won't thank me for saying that.
We all are. All right, Marcus, what's in your roadmap?
Yeah, so we're on base L2. You can use Ubitel to get secure anon internet service in 190 countries right now. But we want to expand. Thank you. Expand to our sort of bespoke more network state solution. So we're rolling out some Docker images, things that make it really easy for you to contribute to actually adding bandwidth to the network, to the open bandwidth market. So, set up your own Wi-Fi radio, set up your own cell phone radio, and start contributing. But one of the other pieces of hardware that we're it's kind of like next up for us to launch is the teapot. So this is our, small TEE that sits inside of a secure element, and we're shipping this out so that basically you can start verifying our L3 testnet and start earning points for doing. But the idea is to obviously, distribute these teapot TEEs around the globe as much as possible to create cool new, secure compute applets that secure our networks, that secure other networks, stuff like this. So that's kind of what's on the chopping block for the next quarter for us.
When space, Marcus? Are you guys putting nodes and sims in space yet? If not, I have some guys you might want to talk to.
Would love to. I talked to an exact guy the other day, so pretty bullish on that. Probably be curious to see what kind of licenses we need. I know I need like an S to beam some stuff back to Earth, but this could all be done in the grand scheme of things. So once we get that orbital capacity, we'll let you all know, and then we'll go to Mars.
When actual moon.
When
Jupiter's moon.
Shoot. Yeah.
Yeah, I mean, look, also for us, so we actually, speaking of roadmap, we have our next acceleration cohort starting in March. Applications are currently open until the end of this year. So for the ones not familiar with the CV Labs Accelerator, it's a 10-week program run twice a year. The first 2 weeks are always in person here in Switzerland. We have the pleasure to invite some people, from, for instance, Midnight or Zama, but also we have in our co-working space here, Solana Foundation, Cardano Foundation, and some others that come by. And I think it's a great opportunity to meet our ecosystem, but also the other entrepreneurs. And afterwards, it's a 8-week remote programming, first block being more focused on product, tech, legal, for instance, workshops on technical roadmap, tokenomics, token design. But then there's also a second block more focused on marketing, go-to-market, but then also investor readiness, given at the very end of our program, we have our demo day with roughly 100 VCs that would join demo day. So for instance, we actually had our last one last week. The projects had the chance to present to some VCs like Dragonfly, A16Z, Archetype, and some others as well. So that's obviously always a great opportunity. And the program also comes with funding. So we invest 150K into each project going through the CV Labs Accelerator. And actually, we have a quite exciting announcement that we can also make is that one of the Ethereum co-founders, Anthony Diorio, will join us as a mentor for the next and upcoming acceleration cohort. So obviously, it's a great opportunity to apply and be part of this cohort. I'd also be interested to learn more about what you're building with programmable cryptography or just generally in the blockchain space and beyond. So make sure to sign up and let us know what you're building. With that, I would thank the panelists so much for joining today's session. Very, very interesting. I think it's a huge topic and we're going to hear more about it in the coming years for sure. As we heard, there is a lot on the roadmap for Zama, Midnight, and Ubitel. So make sure to stay tuned and listen to their updates. All right, guys, thank you so much. It was a big pleasure.
Thank you, Bastian.
Thank you
you
so
guys.
much.
Have a great week.
You too.